Today we start sequence based question which came in the year June 2009. The question is supremum of the sequence root n plus 1 minus root n and lim supreme of root n plus 1 minus root n are. First option is root 2 plus 1 and 0. Second option is 1 upon root 2 plus 1 and 0. Third option is both equal to 0. Fourth option is both equal to root 2 plus 1 upon root 2 plus 1. Now we start here the solution, and we are going to solve here. Let the given sequence is given. Sequence is an, suppose, and that is equal to root n plus 1 minus root n. It can be written as an, that is equals to root n plus 1 minus root n multiplied by root n plus 1 plus root n divided by root n plus 1 plus root n. That means we here rationalize the sequence, and after it, this is root n plus 1, that means a minus b into a plus b. This becomes n plus 1 minus n upon root n plus 1 plus root n. N and n is cancel out here. This step cancel out here, and it will be equals to 1 upon root n plus 1 plus root n. Now limit n tends to infinite an is equals to limit n tends to infinite 1 upon root n plus 1 plus root n. Alright, we put in place of n, that is infinite, then infinite plus 1 infinite, and plus infinite becomes infinite. That means 1 upon infinite is equals to 0. Clearly an tends to 0, limit of an tends to 0 as n tends to infinite. Therefore the sequence an converges and converges to 0. Okay. Now, in case of convergent of sequence, we see in case of convergent of the sequence, we see that limit supremum of an is equals to limit infimum of an is equals to limit n tends to infinite an. Alright, and we know that limit n tends to infinite an was 0. Therefore, limit supremum of an, limit supremum of an, this is equals to 0. Alright, limit supremum will be equals to 0. Now, to find supremum of an, okay, to find supremum of an, since an, as we obtained there, 1 upon root n plus 1 plus root an. Clearly, it is decreasing sequence. Alright, it is decreasing sequence. Therefore, the supremum of the sequence will be even. Since this is decreasing sequence, therefore term A1, since A1 is greater than A2 is greater than A3 and so on. So the term A1 is maximum, therefore supremum will be the A1. Now, therefore A1 is equals to, put in place of n is equals to 1 upon 1 plus 1 whole of the root plus root 1. This is equal to 1 upon root 2 plus 1. Therefore, supremum of an will be equals to 1 upon root 2 plus 1. Right? We see the question supremum. Okay, right? So we see the question. We have to find the supremum of root n plus 1 minus root n, and we have limit, so that is root n plus 1. So first option, the supremum is 1 upon root 2 plus 1, and limit n tends to infinite, and limit supremum an is equals to 0. So we see the option. The first option, root 2 plus 1 and 0, this is wrong. The second option, 1 upon root 2 plus 1 is the supremum, and 0 is the limit supremum of an. Right? So second option is correct, third option is wrong, and fourth option is also wrong. Alright? So this is we see the next question. that is came in the year 2009. If an is equal to n square plus minus 1 raised to the power n upon n, where n belongs to capital N, then sequence an is, first option is an is convergent but not Cauchy. Second option, an is Cauchy but not convergent. Third option, sequence an is not Cauchy but bounded. Fourth option is does not have convergent subsequences. Now solution. An is equals to, this is given there, n square plus minus 1 raised to the power n upon n. En belongs to natural number. Alright, we see here odd and even natural numbers. That means we have two complementary subsequences here. That is A 2n, or you can say A 2k, and A 2n minus 1. This is for even and this is for odd. Two complementary sequences. Now this is this and this. Now A2n. We know here A2n, that is equals to n square, and this is even, therefore this is 1 by n. Alright, and A2n minus 1, that is here n square and this becomes minus 1, for odd values 1 upon n. Now find limit n tends to infinite A 2n, that is A 2n, that is equals to infinite, and limit n tends to infinite A 2n minus 1, also this is equals to infinite. So as we see here, these two subsequences are not convergent and are not convergent. Since the complementary two subsequences are not convergent, that means divergent, right? So the given sequence not convergent. Alright. Also we see here, since the sequence is not convergent, okay, and the limit was infinite of the complementary subsequences, therefore since this is also not the convergent, so not bounded. Alright, not bounded. So we see the option. First of all, the first option, an is converges but not Cauchy. So as we see here, the sequence A is not convergent, so first option is wrong. An is Cauchy but not convergent. We know that Cauchy sequence is already convergent, so second option is also wrong. Third option is sequence is not Cauchy but bounded. As we see here, the sequence is not bounded, so third option is also wrong. And the fourth option does not have convergent subsequences is the correct option, right? Thus option 4 is correct. Since the subsequences are the divergent sequences and it does not have the convergent subsequences, 4 option is the correct option. Now we see another question which came in the year also in 2009, right? Limit supremum minus 1 raised to the power n upon 2n, n belongs to capital N, is first option is 0, second option is 1 by 4, third option is 1, and fourth option is minus 1. Okay. Here, given that, suppose the given sequence is an, that is minus 1 raised to the power n upon 2 to the power n, where n belongs to capital N. Now, as we know that limit n tends to infinite an, that is equals to 0. And sequence an is convergent. This is the convergent sequence. And its limit is equals to 0, and its limit is 0 there is a result if the sequence is convergent, and if the sequence is convergent, then limit supremum of the sequence is equal to limit infimum of the sequence is equal to limit of the sequence. Therefore, since here the sequence is convergent, therefore limit supremum of an is equal to limit infimum of an is equal to limit an. Alright, limit an. As we obtained here, limit an is equals to 0, so therefore limit supremum of an is equals to 0, as we know. Thus option first is correct. We see here limit so is 0 is the first option, so first option is correct, second is 1 by 4 is wrong, third is 1, and fourth is also, third also wrong, fourth and also wrong. So thanks to everyone.